The night was still when it began. A thin ribbon of light arched upward from Hainan Island, piercing the darkness as if carrying with it the hopes of a billion hearts. On December 1st, 2020, the Chang'e 5 spacecraft rose into the sky, its firelit tail vanishing into the stars. For the engineers watching from the launch pad, it wasn't just metal and fuel. It was a leap toward a world humanity thought it already understood. For decades, the moon had been a place frozen in time, silent and unchanging. Our visits were brief, our knowledge pieced together from dusty footprints and shallow scoops of soil. But the Chang'e 5 wasn't built for nostalgia. It was built to dig deeper, literally into the moon's skin, to pull up its buried stories and bring them home. Nearly 8 tons of carefully engineered machinery equipped to travel across space, land with precision, and return with treasures no human had ever touched. Its destination was unlike anywhere we had been before, a place called Oceanus Procellarum. The name Ocean of Storms sounded poetic, but it was no ocean at all. From above, it looked like a vast, dark plain of volcanic rock, flat and silent, stretching beyond the horizon. Towering over it was Mons Rimker, a colossal mountain rising more than a mile high. The mountain had stood there for billions of years, a frozen monument to the moon's violent volcanic past. No astronaut had set foot there. No robotic arm had ever sifted its soil. It was a place untouched, holding secrets in the silence. When Chang'e 5 descended, dust swirled upward in slow-motion plumes, the only movement in a land where nothing had stirred for ages. It landed gently, almost respectfully, on that alien surface. For the first time, this forgotten corner of the moon had a visitor. Cameras transmitted its surroundings back to Earth. Jagged shadows, glinting grains of dust, and the ghostly outline of Mons Rimker looming like a silent guardian. The clock was ticking. The moon gives no warmth, no protection. Every mission there is a race against time, against the bitter cold of night in the scorching heat of day. Chang'e 5 had just 2 weeks to complete its task. Within hours, the drill began to bore into the ground, twisting through layers untouched for billions of years. It dug deeper than any mission in decades, piercing the moon's dusty armor and reaching the ancient bedrock below. What it brought up was more than just rock. It was a story, written in minerals, in tiny crystals, in glassy beads that had formed in moments of unimaginable violence. Each grain was a fragment of history, a relic from an age when the moon was young and restless, its surface shaped by eruptions and bombarded by fire from the heavens. And hidden in those grains was something no one expected, something that would ripple through science, through exploration, and maybe one day through the way we live on Earth itself. It began as a quiet observation in the lab. The scientists, gathered around the sealed containers in a sterile white room, leaned in as the first layers of lunar soil were spread beneath their microscopes. Among the jagged dust, they spotted tiny, perfect spheres, like frozen raindrops. These weren't ordinary rocks. They were glass beads, no bigger than a grain of sand, formed when meteors slammed into the moon's surface, with such force that stone melted, then cooled in midair. Inside those beads, trapped for eons, was water. Not ice hiding in shadowed craters, not frost clinging to the poles. Water, locked away inside millions, perhaps billions, of these microscopic glass droplets scattered across the moon. It was as if the moon had been quietly holding a secret beneath its dusty veil, waiting for the right hands to uncover it. Each bead contained only a whisper of water, almost nothing at all on its own. But together, the numbers began to swell into something staggering. If you could heat the lunar soil, just 1 metric ton of it, you might draw out 2,000 liters of water, enough to sustain explorers, enough to grow food, enough to make rocket fuel, enough to change the way we imagine living on the moon forever. The implications began to unfold in the minds of the scientists. The moon was no longer a barren, bone-dry desert. Water wasn't trapped only at its frozen poles. It could be gathered almost anywhere, right beneath an astronaut's boots. Suddenly, the vision of human life on the moon didn't feel like a distant fantasy. It felt possible, yet the water was only part of the revelation, because those same ancient layers held something else, something rarer, something that could, if we dared to dream big enough, alter the future of energy on Earth. And deep within those samples, hidden in the moon's oldest rock, the world would soon learn of a discovery that could ignite a new kind of race. Not for land, not for gold, but for the very power that lights our cities and drives our world. The glass beads were enough to make headlines. But as the Chang'e 5 samples were cataloged and analyzed, another thread of the moon's story began to emerge. One written not in water, but in the language of atoms. It was buried deeper, in the fine, powdery regolith, in crystals that gleamed faintly under the laboratory lights. These minerals were unlike most found on Earth, born not in oceans or forests, but in the furnace of ancient lunar volcanoes. Among them was something that made the scientists pause, check, and recheck their readings. Helium-3. On Earth, helium-3 is vanishingly rare. We can detect it in trace amounts, sometimes in the exhaust of nuclear weapons tests, sometimes in the decay of tritium, but never in quantities worth harvesting. The moon, however, has been bathed for billions of years in the unfiltered solar wind. Without a magnetic field to shield it, its soil has quietly soaked up helium-3 like a cosmic sponge. And here it was, in measurable amounts, locked into the lunar dust. Helium-3 isn't just another noble gas. It is, in theory, the perfect fuel for nuclear fusion, the reaction that powers the sun. Unlike the fission reactors we use today, fusion produces no long-lived radioactive waste, no carbon emissions, and carries no risk of runaway chain reactions. A single ton of helium-3, scientists estimate, could generate enough power to meet the needs of a major city for an entire year. If the fusion problem can be solved, and that if still looms large, helium-3 could light our homes, power our industries, and propel spacecraft across the solar system without poisoning our planet. The numbers are seductive. The moon may hold over 1 million tons of helium-3. That's enough to meet Earth's current energy demands for centuries. But the challenge isn't just in using it, it's in getting it. Each ton would require mining and processing hundreds of millions of tons of lunar soil. It would mean building machines to survive in brutal temperatures, endure abrasive dust, and operate in low gravity, all hundreds of thousands of kilometers from home. Yet for the first time, the barrier wasn't ignorance. It wasn't that we didn't know where to look. Now we knew exactly what was up there. As news of the find spread, boardrooms, space agencies, and governments began to hum with conversations that felt half like science fiction and half like the opening moves of a new geopolitical game. The moon, long seen as a dead world, was starting to look like the Persian Gulf of the 21st century, a place whose resources might shape the fate of nations. But there was a more immediate question, a quieter one, yet no less profound. If the moon truly held the keys to both survival in space and clean energy on Earth, who would claim them? Would it be the work of an international coalition, guided by shared principles? Or would it become a scramble, each nation staking out its slice of the moon's dusty plains, just as empires once carved up Earth's continents? On a cold morning in Beijing, one of the Chang'e mission scientists stepped out of the lab after another long night of analysis. Above her, the moon was visible in the pale daylight, a pale, distant coin hanging over the city. She thought of the glass beads, of the helium-3, of the volcanic mountain where it all began. She thought of the generations before her, who had looked at that same moon and seen only beauty. And she wondered, when her grandchildren looked up, what would they see? Because in the years ahead, the moon would no longer be just a light in the night sky. It would be a prize, a workshop, a home, and maybe, just maybe, the place where humanity learns to live among the stars. It was the first sunrise over Oceanus Procellarum in the new year of 2069. The sunlight crept slowly across the black horizon, spilling over the jagged rim of Mons Rumker, turning the volcanic slopes gold. From her observation deck, Commander Lian Zhou watched the light crawl across the lunar plain toward Lunar Base Kepler. The base wasn't much to look at from a distance, just a scatter of domes and angular towers connected by silver tunnels. But to those who lived there, it was a city, a living, breathing outpost. The air inside smelled faintly of metal and warm soil from the hydroponics gardens. The hum of water pumps and oxygen scrubbers was as constant as a heartbeat, and outside, just beyond the walls, was a world of silence and dust. They called it the Chang'e generation, the engineers, scientists, and builders who had grown up knowing the moon was no longer unreachable. Chang'e 5's discoveries, nearly half a century old now, had been the first domino. The water locked in glass beads meant they could drink without hauling every drop from Earth. The helium-3 in the soil, once just a theory, now fueled the first fusion reactors that lit not only the base but half of the cities back home. The mining field stretched toward the horizon, where robotic harvesters sifted through endless gray regolith. Conveyor belts carried the soil to the processing plants, where heat extracted the precious helium-3. Just beyond, in the shadow of the mountain, a row of solar furnaces baked the dust to release its hidden water vapor, which condensed into shimmering storage tanks. Inside the base, children ran through the corridors under artificial gravity fields. Some had never been to Earth. They learned to walk in spacesuits before they could ride a bike. In the greenhouses, rows of wheat and tomatoes swayed gently under the lamps. Farmers here wore pressure suits instead of overalls. From the communications room, Earth was just a click away, but also an eternity. The home planet hung in the sky as a glowing blue marble, so heartbreakingly beautiful that even the oldest lunar settlers still stopped to stare. For Leon, born on Earth but shaped by the moon, that view was a reminder of why they had come here. Not to escape home, but to save it. And yet beyond the quiet triumph, there were whispers of tension. Other bases, built by other nations, now dotted the moon. Some cooperated. Others eyed each other warily, their territories marked by invisible lines across the dust. The old questions had not vanished, only moved farther from home. Still, as the first rays of the sun reached the base and bathed it in light, Liana allowed herself a rare moment of pride. She thought of the scientists in 2020, huddled over the first Chang'e 5 samples, astonished by what they found. They had stood at the beginning of something they could barely imagine. Now she stood in the middle of it. Out on the plain, a group of students, new arrivals from Earth, stepped carefully onto the surface for their first lunar walk. Their boots pressed into the regolith, leaving crisp prints that might last 1,000 years. Above them, the Earth shone. Beneath them, the moon hummed quietly with human life. And somewhere, locked in the soil beneath their feet, were still more secrets waiting for another generation to find.